Hello everyone.
Hello.
Professor and everyone. So this is our project of building environment control.
Yeah.
And we want to introduce you the basic structures and the framework of our project. So let's start.
Okay, now I will introduce our structure of the system. You can see here we have actually 4 modules: the server, the control, and the sensors and the actuators. In our test, this PC will be used as a server module, and the Raspberry, this one, will be used as the control. The control module will be on it, and the sensors and the actuators. Since the lack of the equipment, we just use 3 fake sensors: the fake DHT11, the fake user presence, and the fake air quality sensors in room 1 on this computer, and a fake heater in room 1 on this computer. I will start from the sensor module. In code, it has 3 classes: the subscriber, the publisher, and the server. And it provides 3 services. One is the setting page. It will use get to modify the settings and to let the user to check the status of the system. And the freeboard and the scene spec I will introduce in detail in these pages. The setting page, it can set the desired environment of each room. It can add a new room to the system, and it can delete the room from the system. Of course, it can check the status. Here's the page of the setting web page. You can see here is lines for setting, here's for add a new room, and here's to delete the room. The most important service, I think, is the freeboard. It will show almost all the information of each room: the temperature, the humidity, the air quality, the user presence, and the status of every actuator. Due to the maximum columns of the freeboard, it can only show 5 rooms. The third service it can provide is the scene spec. The only usage of this service is to change the temperature of the monitored rooms up to 8, since there are only 8 charts of each scene spec channel. The control module is the most important part in our system. It has 4 classes: the subscriber, the publisher, always these 3 is the most important, and the control global and control room. The control global and the control room I will introduce in detail in the next pages. Here's the UML graph. Just skip it. To store the information about the system, about every rooms, here I use a structure like this. It contains dictionary and dictionaries. You can just see this. I will not introduce it in detail. And to control every room, it has 5 steps. 2 is on message in the class subscriber, and the other 3 is in control room class. First, it will subscribe and store the user settings of each room from the topic, which or the settings is published by the service, the server module, and then it will meanwhile it will subscribe and store census data of each room from the topic of each sensor in each room. Then it will calculate the environment of the room by the census data, because we consider in each room there can be several DHT11 sensors to get an average environment. Then it will compare the settings and the environment of each room, then decide the status of each actuator, what they should do, and store the actuator's status and publish them to the topic so that each actuator can subscribe them. Here's some detail about the class subscriber. Since the control module is the most important part in our system, it also have quite complexity data operation. From here you can see from each topic it will do the different operations. To add a room, to delete a room, to update the settings of the certain room, or update the sensors information of the certain room. Here's the 3 steps in class control room I just described before. Okay, here's the part of the sensors and the actuators. She will describe it.
So here's the basic framework of the software structure. As you can see here, I have faked sensor data into a data.txt file, and this A stands for air quality, T stands for temperature and humidity, and in this part you have 3 scripts called sensor A sim, T sim, and O sim. These are basic functions to simulate the data. Also, these 3 functions will get default data from a data simulator. This is a script which can grab data from real website, for example, weather.it. This website usually provides real-time weather information, so it is reasonable to use the data collected from here, because if we simulate, for example, in winter Turin, 30 degree, it is not so reasonable. So basically from here we have the fake data. So we have a sensor publisher which reads data from the fake data, which is written in the data.txt, and the sensor publisher has an inheritance relationship with the sensor. The sensor is initialized by a file called the sensor configuration file. So once the data is collected, it will connect to the broker and publish the data to the broker with a given specific topic. So after that, the sensor actuator will subscribe from the broker. So also similarly, it has the inheritance relationship of actuator, which is also initialized by a configuration file, as you can see from here. So here, once we have done this, you can see here this A1 stands for air quality sensor 1, and this O1 stands for occupancy sensor 1, and the structure are the same, all occupied with data.txt, which is fake data, and sensor configuration, which will initialize each sensor, and the sensor publisher and is the main function running. And as you can see here, all data text and sensor configuration. So this is the basic structure from the framework. Thank you.
And the most important thing in this system, I think, is in any time we can add or delete any sensors or actuators or ROMs from or through this system. I think it's the most important, so that we can easily to use this to manage the environment of a whole home building. Thank you. Then we will start to test use true PC. One is used as a server, and another is used as the sensors and actuator, and one is very used as a control module. Okay, thank you.
Thank you.
Okay, now we just open every modules on each PC. We can see here the temperature and the humidity and the quality is always change every 10 seconds actually. And when the occupancy is 1, it means there's people inside, the actuators will work. Here we can set the desired environment. You can see here we set the temperature be 25 and the humidity be 40. Okay. Let's check if it is received. Yeah. Now the occupancy, if it's 0, every actuator will stop working. Now the occupancy is 1. Since the temperature is smaller than 22, since our threshold is 3 degrees, the heater it was 1. Now it's off because it's already over 22. So humidifier is always on because we can see the environment now is quite dry, and the air quality is not bad now, so the fan is not on. And I will introduce the second operation of the setting. We can add the new room to the system. Here I add a room ID is 3, and in this room it only has one actuator, the heater. We call it H3. Okay. Now you can see here the new room is already added into the system, and there's only one actuator is shown here. Since we don't have sensors now in that room, and the sensor the information about the sensors is provided by the sensor itself when it's published to a topic, and the control module will automatically to detect it. It is not the user's okay. Also, we can delete the ROM from our system. Now I just delete the ROM 1. There's a bad news that the freeboard can't delete the presentation on it. However, you can see it will never change anymore. It means it's out of the system already. We add it back. Okay, wait a second. Now it again in the system. We can see here the scene spec is always change. Don't mind this long distance. Now, okay, it's okay now. It will show 20 points on it, and it's temperature trends. Here we can see the status of the actuator side. This is the heater in zone 1, and we can see the status of the heater is change.
So once upon receiving a message, as you can see from here, the status is 1. The old status is checked and is 0. You receive a new message, so you have a status change from 1 to 0 to 0. No, it's from 0 to 1, so that the actuator is open. It means the heater is on and the new status is enabled. And if we recheck the current status, it becomes from 0 to 1, so it's working. And also this actuator subscriber has a function of checking the timestamp of messages. If it is a new messages, you can see it received the messages successfully, but if the timestamp is not satisfied, this is an old message, so that this message will be discarded and ignored.